Everyone, welcome to the new episode of Streaming Caffeine. This is Jove. Today we are inviting Yaroslav enjoying this talk. We're actually in the same town in Vancouver. We even talk about meeting in person in a park, but suddenly this week there's a lot of rain and it's cloudy right now. I don't know whether anytime there will be rain, so it will be easier just using Riverside to meet virtually. I did prepare some coffee just in case we will meet in person, but I just drink one. Yaroslav, before you talk about yourself, what kind of caffeine element you bring to the show?
Yeah, thanks for inviting me. I don't have any coffee, but I do have some green tea right here. So I think that's enough caffeine for me for the morning.
Okay, cool. Yeah, so let's enjoy the caffeine and the topic of the streaming. Yeah, I met you in one of the coffee shop. I forgot, maybe half a year ago in Starbucks, and I didn't watch your last talk in current in person, but I watched the recording, and I thank you for mentioning Timeplus. Even we are at early stage, definitely we'll talk about in this episode regarding what's your favorite topic in current stuff like that. But before that, for those people who haven't followed you closely, like myself, I read every single blog you've written. So
Thank you.
can you share a little bit about yourself and how you are getting into this streaming and what's your overall experience to work with the community? Yeah.
For sure, yeah. So my background is actually in web development, full stack web development. So I spent several years working for some startups here in Vancouver, but about maybe 6 years ago or so, I transitioned into data engineering world, and I worked for Activision, so a company behind Call of Duty games, Shopify, and now I'm with Goldsky, which is a Web3 data platform company. So we provide different tools to build data pipelines, and it's basically like a managed data streaming offering, but with blockchain flavor, right? So you get access to any of the data on the blockchain you want, and we make sure things work nicely for you, and it's very developer friendly, very easy tool to use. And yeah, it's been all about building a good data streaming platform at Goldsky, but of course, dealing with blockchain data, it adds some additional complexities. So happy to chat more about that. But yeah, so that's my journey so far. I guess I've been mostly doing data engineering with streaming in those last 6 years, but also managed to touch a lot of the batch workloads, databases, and all the typical data engineering tools and projects and challenges you have.
Yeah, that's awesome. And I guess many people, including myself, enjoy reading your blog because you are talking about the real stuff, right? There's not lot of marketing or kind of too general. You are really digging into the details because you have a lot of first-hand experience. That's amazing. And I can imagine we can talk about topic today. I'm not sure I will 100% agree with you, but that's a very interesting discussion. People may have different opinions. That's perfectly okay. That's also the purpose of this talk, right? So we are not really doing any kind of marketing. It's really about we have so much passion about this data streaming. So maybe we can start from the current, right? So I'm not sure how many current or Kafka Summit you joined in person.
3, 4, probably by now.
Wow, nice. Yeah. So I'm sure you have the other talk this year, and you have a talk last year. You might have a talk earlier. So, what is the topic for this year? And is there any? Yeah, we don't really do any screen sharing, but can you share some of the kind of interesting topic you may want to join in person or recommend our audience to watch or join in person? Yeah.
Yeah, for sure. Current is always a great event, as well as Kafka Summit. And my talk this year is called Dynamic Change Data Capture with Flink CDC and Consistent Hashing. Bit of a mouthful, like lots of buzzwords mentioned, but Yeah, as you said, I really wanted to share some of the hands-on experience, right? And a lot of the talks and resources online, when you read about change data capture, that they explain the concepts, they explain how you can do something like Debezium, maybe with Kafka Connect. And it's pretty much straightforward when it comes to managing more or less static set of tables, right? So maybe you have 20, 40, 50 tables in a database that you want to ingest into Kafka. And it can be as simple as just having some kind of regex or listing all those tables. You deploy it once, things keep running, you monitor them, data is flowing, right? And then maybe eventually, like once in a few months or so, someone comes to you and asks like, hey, can we also ingest this table, right? And you kind of redeploy things. And so it's a very static infrastructure, I feel like. And also when it comes to Postgres, so we use Postgres internally, and we need to build a lot of the systems around Postgres. And so when it comes to Postgres, it has a concept of a replication slot, which is used as a kind of way to replicate data. And this is something that typically CDC technologists like Debezium use. And so with replication slots, it's a bit of an art because you don't want to have a lot of those slots opened, right? Each slot consumes a bit of resources on the database, so you can't really have hundreds of slots open. I believe the default limit on AWS RDS is 20, right? So, and you probably also don't want to use a single slot because you can't really parallelize your data ingestion that much, right, with a single slot. And we ended up with this kind of challenge, right? Because in our case, we use Postgres to drive some of the internal kind of data ingestion mechanisms. The list of those tables that we need to ingest, it's basically driven by our user requests, right? So maybe a user deploys a thing. I'll explain later what we do, right? But maybe you deploy something, and that deployment results in creating multiple Postgres tables. And so we need to dynamically kind of understand that those tables should be ingested, and we can't simply allocate as many replication slots as we want, like new slots, because again, that's like a resource that's not free, right? And so the approach that we took was essentially having a pool of those replication slots available and sort of dynamically changing the list of tables you ingest, adding tables, removing tables, and all of that is driven by user requests, right? So it's kind of a user-facing system in the end. So very interesting, lots of challenges, lots of lessons learned, and yeah, happy to present this with my coworker, Zhao.
Yeah, this is already a quite in-depth introduction, right? Or kind of a peak of your talk, even like a rehearsal. So yeah, I'm sure there'll be a lot of real stuff being talked. And so, by the way, this is your like not really the second talk in current, right? I guess you may join like 5, 6, and you have presentation almost every time.
I presented before at Kafka Summit a couple talks about our data pipelines for Call of Duty games at Activision. So
Okay,
some of
nice.
the interesting lessons learned as well there.
Oh, that's awesome. And so again, yeah, I definitely will check the time of your talk and mark on my calendar, join myself to my best effort. And what
Thank you.
other topic you really recommend in this conference?
So I love watching keynotes. I think keynote is always, a great time for announcements and really understanding, the direction that companies like Confluent take, for example, right? So keynote's definitely a
Yeah,
great
yeah. By the way,
opportunity
that
to
is,
learn
I
more.
guess, as a speaker, we somehow work very hard to making sure our slide deck, even our demo or whatever, is well prepared. I feel kind of mixed feeling for people in Confluent, right? So as an engineer, we know that it's a big milestone. You have to release all those stuff with the high quality. So
Yes.
I'm sure there'll be a lot of big announcements, and engineering team or creative team in Confluent can be very busy right now in August and September.
And I did have some other talks, so I spent some time recently going through the agenda, and I think it's a great event. Um, I love hearing about customer stories, right? So companies sharing kind of their journey, but also some pretty in-depth, technical deep dives, right? So what I have on my list, what I wanted to share with the audience, right? So I recommend hearing about Restate. So the talk is called Restate Stream Processing, but for microservices. And this is a talk from Stefan Even, who was a CTO at, I believe, Data Artisans first, then Verberica, so the company behind Apache Flink. And Restate was just announced a few days ago. There's a great blog post, and it's a framework that's inspired by stream processing, but it was designed to work really well for microservices, so RPC-based microservices. And it uses the concept of log to persist a history of events and commands that happened, and it has just like some very cool primitives. So I'm very excited about that talk. Similarly, pretty interesting deep dive I'm expecting to hear from guys at Rockset. Rockset is one of my favorite OLAP engines, and they're going to be talking about isolating streaming ingest and queries using RocksDB. RocksDB is a pretty foundational part nowadays in pretty much any streaming engine when it comes to state management. So very, very interesting to see how they use it. I think, Ryan from LinkedIn is going to talk about deeply declarative data pipelines. And I believe this talk is a new framework that they have that allows you to deploy streaming pipelines just using, a single YAML file, maybe with a bit of SQL configuration. And this is very interesting for me personally, because at Goldsky, we are trying to achieve the same, very declarative pipeline definition configuration, where you don't need to think about anything except this like very high level declarative config. So hoping to learn something from LinkedIn folks. I also recommend checking out Adam Belmer's talk about data mesh. It's called Off-Label Data Mesh, a prescription for healthier data. Adam is pretty vocal about why data mesh should be, leveraged in every single company. And I think in this talk, he explains the value, not just data mesh as a data platform or data engineering concept, but data mesh as a company-wide concept, where you would put your operational data sets into the data mesh as well. And that's usually required because most of the analytical data, not most, but a lot of the analytical sources come from operational sources, right? So you kind of need full lineage there. I would love to hear about learnings of running Kafka tiered storage at scale from Uber. So I know Uber has been developing tiered storage for the open source Kafka for a while. And I think it will be hopefully released very soon, maybe in the next major version of Apache Kafka. And I personally think that tiered storage is extremely important when it comes to the adoption of data streaming kind of as a default architecture. So just excited to hear any news about tiered storage, any developments. And I would love to hear about why serverless Flink matters. This is a talk from Confluent, and I think everyone is expecting to see this new offering from Confluent that provides Flink SQL, or in the future Flink data stream APIs. So yeah, just very, very curious how that's built, what kind of features, capabilities they provide, because I'm building a similar product in the end. And finally, I heard that someone from Timeplus is going to be presenting about querying streaming data with SQL. So maybe you can spend a bit of time telling us what you're going to talk about, Joe.
Yeah, sure, cool. Thank you for mentioning that. I guess I will do some post editing about this, and I will share that link down there here or there. I'm not quite sure. So thank you for the list. I'm going to talk about querying data in Kafka using SQL with different options, no matter it's open sourced or like commercial or cloud offering. So again, Timeplus is just one of the options, but there's many ways, depends on your use case. Right? For example, whether you're really looking for a certain sophisticated join or time window, or just to do some flat transformation, or do you have already OLAP system, or prefer having a unified system like Timeplus to do all the streaming and the batch processing. So anyway, that will be a topic. And again, I guess you have, when I read your message on LinkedIn, you also do similar study, even you cannot join the London Kafka Summit in person, right? I guess I saw something like this. Hey, this is all the videos I watched for like over 20 hours, and this is the top one I really recommend. You have very good learning habits.
Thank you.
Quite impressive. Yeah, so I will share the list in part of this. If you get this from YouTube or Spotify, also put in the description. So by the way, that is, I think you also start writing a series of blog, maybe weekly basis, right? So can you share more about that too?
Definitely, yeah. So I guess in July I started this newsletter called Data Streaming Journey, where I try to regularly publish different ideas, different deep dives, some explanations about the concepts that I see that I think are challenging or maybe misunderstood, or just trying to share my experience in this area. And so far, it's been great writing, hearing feedback, so I'll definitely continue doing that. And I don't know, I always wanted to write more, and I do have a blog, and I've been writing there for about 10 years, I think, but I never had sort of any kind of external pressure, to force me to write things regularly and share with people. So yeah, I thought maybe sharing that I have this newsletter publicly will kind of force me a little bit to be confident and start writing regularly. So far I think it's going well. And yeah, so it's called Data Streaming Journey, and it's about all kinds of things related to data streaming. I think data streaming, and I'll happy to talk more about this, but I don't think data streaming is nowadays purely used for data engineering or building data pipelines. There are so many more use cases, and just the concepts behind it, as well as event sourcing and event-driven microservices, like it's all very, very similar. And just really studying that, even if you're not building data pipelines, or if you're not interested maybe in data engineering that much, but you're building event-driven microservices, there are still a lot of the similarities there. And yeah, I just hope to share what I've learned so far.
Cool. Yeah, I usually read that on Monday, right? Is that you spend some of your weekend to write a blog, or it's more like week-long effort?
I do try to prepare, and maybe I'm going to be switching to bi-weekly because
Okay.
it does take a bit of time to prepare. I don't want to be publishing things that are like very easy, like one-on-ones tutorials. I want to go a bit deeper. But yeah, maybe a chance to promote Goldsky a little bit. So in Goldsky, as one of our perks, we actually have every second Friday is our self-care day. So essentially, it's a day off,
Wow.
and
Nice.
people choose to do different things, different ways to use this time. And recently, I decided I'm going to spend this time writing, right, and writing for the blog or the newsletter.
Wow. So it's really a special version of Happy Friday, right? It's more than say when I was in Splunk, other companies, like Friday afternoon, there's a lot of chat or even like alcohol in the office, right? So I'm not sure that's appropriate, but people really enjoy this chat to each other, not just in the same code team, but maybe from different departments. Sometimes they can even come up with very good ideas to refine certain things, or even work on certain new product or patent. I guess what you mentioned in the Ghost Guy is even the next level, right? It's self-caring, like it's like hug yourself and also do whatever meaningful to make this one day more meaningful and special. Yeah, this is a very good program. I really admire that. Yeah, I mean, no pressure. I think you being very active and always consistent on different media like so LinkedIn, Twitter, and people like reading your stuff, right? So I know.
Thank
I mean,
you.
as kind of a co-founder slash head of products doing some kind of amateur marketing, I know content marketing is important. It's must have for the team, for the company, but there's so many different ways. You can easily hire someone to content marketing, generate a certain content, a blog, whatever. Even right now using AI, right? And I guess I'm training a model in my head to see, hey, this is primarily written by AI, this is by human being. And every time I read your blog, this is so kind of like talk to a real person, and I really enjoy reading that. Maybe people may looking forward to having reading a book from you, but again, no pressure. This we don't have to like fix the schedule, a certain target. As long as you have good stuff to share, we'll be at all ears. Yeah.
Thank you.
Yeah, and maybe we can touch a little bit about the topic you mentioned earlier regarding this data streaming. You've been in this industry for a long time, and I work on data streaming for also quite a long time, but for the past 2 years, just work on this new product like Timeplus. Actually, regarding the use case, it's like, for example, like for a while we think streaming ETL is a concrete use case, but for a while we try to deny that because like we feel like, oh, ETL boring, stream ETL, okay, it's so basic. But when I talk to many customers or partners, it's still a thing, right? People doing a bunch of batches, they want to reduce the latency, they want at least once, etc. once. So many of the kind of use case essentially is like streaming ETL. Even we kind of think the ETL term is kind of out of date, and there's some other folks using like microservices. Do you think like customer may have different stay in different stage? Is that I mean, for the kind of community or the customer expectation, do you think is a rising trend, or people still kind of struggling whether they should spend more effort and make their batch better and worry about streaming like next year? Or is there just too many tools out there, or just not enough tools option on the market? What's your take on that?
Oh, lots of questions there. Lots of complexity to uncover. Well, if you just think about streaming ETL, right? This is basically taking some raw data from somewhere, some data source, a set of data sources, and probably cleaning it, transforming to some kind of representation that's uniformed, right? And putting it in maybe a data lake or data warehouse. If you think about streaming ETL in simply that context, then streaming itself, I think it comes with some advantages, but I think you will get most of them if you're just doing macro batches, right? If you have something like Spark with batch size of a minute, let's say, or even like 5 minutes, I think you'll still get all the benefits when it comes to streaming ETL because as far as I understand, in a lot of those use cases, streaming ETL is just powering your data lake or data warehouse, right? And it's still heavily reporting or ML use case, in mind when it comes to streaming ETL. But for example, what I like to mention to people when it comes to specifically the ETL part is whenever you have a batch job and if it runs for several hours, right, you can have a really big problem when you realize that it failed. So let's say you have a batch job that runs every every 12 hours and it takes 4 hours to run, for example, right, or something. And so, first of all, what do you do with late driving data? That's always a good question. You probably have some kind of partitioning scheme for a data lake, and let's say you have like a daily partition and an hourly partition. So what happens if you have late driving data? How do you deal with this in batch world? And there are no good use case, no good workarounds. I think you have to essentially allow some kind of delay. So maybe when you run for this 4 hours, you kind of waiting a little bit, right, and trying to capture this late arriving data, or maybe when the late arriving data happens, when it arrives, you have to drop it, right, if it's a small percentage. Or maybe if you have something like a lake house format like Iceberg, maybe do like an upsert. But that's also not great because, well, for a variety of reasons, maybe the report that you run, it already like happened and was shared with your stakeholders or something, right? And now we have this data that has to be corrected. So just thinking about that very specific problem, just one specific problem, streaming seems like it can solve this really well, because by definition you have some of the abstractions for data correction, right? Whenever you have late arriving data in your system, with a streaming data pipeline, you can configure different windowing mechanics to specifically configure how much you're willing to wait, and it's not something you have to kind of add on top of your batch system, right? It's part of the streaming engine itself, right? So so windowing with triggers, with late driving data, like all of that is typically part of any modern streaming framework, Flink, Beam, Spark, right? And if you combine it with the concept of upserts, I think it's just a very elegant solution. Whenever you getting late driving data, things can be corrected because you have this very easy kind of windowing abstraction, and you can tell it what to do with the data that's driving late. So that's kind of my just one thing that I like to mention. Think about that late driving data. And the second thing I wanted to share here, whenever the batch job fails, and if it took 4 hours, and you probably spent like an hour understanding the issue, fixing it, grinding it again, and you need to wait another 4 hours, right? So that's at least 9 hours out of 12, and then maybe it fails another time, right? And then you're really violating your SLA. And so streaming just forces you to think like an engineer, right? So you start thinking about, what is my SLA? Do I have a special, like alerting system in place to let me know whenever my streaming job goes down? Do I have a playbook for that? Do I have a team on call? Definitely, it's it forces you to invest quite a bit. But on the opposite side, you get this very mature system that hopefully is more or less resilient to failures, right? So you don't have a scenario where you need to wait for hours and hope that something will be fixed on the second or third run, and you just keep allocating more memory and hoping that this batch job will finish eventually. So streaming forces you to think just like an engineer working on an application, right? Like building user-facing applications where you think about latency, you think about alerting, you think about SLAs, and I think that's healthy. I think especially in a bigger organization, you cannot tolerate waiting for hours for data to arrive whenever there's some kind of failure. So that's something. If we just dig in with streaming detail, and I'm just going to pause here in case you want to comment or share any battle stories.
I know I'm
your
not sure whether
experience.
that's relevant, but there's a certain part of it is somehow similar to this debate of microservice and the monolithic, right? So I know this is not really apple to apple comparison, but to some degree, batch is like monolithic. You have to like wait for, like you just mentioned, 4 hours plus one to see the end to end. Oh, oops, the last 1% of the data pipeline was wrong, and I have to do it again. And the streaming, you might break into a smaller kind of a chunk and apply different stuff. You get feedback earlier, but also causing other challenges such as how to do the proper test, right? How to like backfill, or how to like fast forward or try to train your data without care too much about the real the clock in the real world. There's a lot of stuff. People I know some teams try to invent the way to like you mock every single thing in your system, the file system, the window clock, so that you have a certain way to measure it, no matter when you test it, how long you test it. Yeah, there's a different problem. But again, yeah, it's again, we all feel very passionate. This is can be a solution to get more real-time feedback, to even save the cost, right? And for example, in Timeplus, we are doing a lot of enhancement on the data joining part, and this is very different than doing join optimization in the traditional OLAP, right? So in the traditional OLAP, you worry a lot of how I design the file system to making sure when I run a query, I only fetch the minimal amount of files and do the stuff. There's a bunch of like cost-based optimization stuff like that. But in the case of streaming, you are not really talking about the entire data set. You are talking about the data, maybe a few thousand or 100,000 of data per second. It won't be as huge as like a huge data lake in Snowflake. So the way you cache data, how you do the joining is very different. So yeah, again, I think outside this technical internal stuff, customer really want something quicker feedback, and they can even change certain data if they think the certain data in the past was wrong, and those stuff is help them to act faster in the real world, catch the opportunities or prevent bad things happen or have a bigger damage. So I think with the expectation is getting higher. Like people
exactly.
saying, I really want to get to my pizza sooner. I know where my Uber car is. All those stuff increasingly like help everyone, including those decision makers, to say why I have to wait 5 hours to get my report. Can I get now? Right. So again, streaming is one.
That's something actually. Yeah, that's something I wanted to elaborate a bit because you originally asked about streaming ETL, and I think now it's just a part of the picture, right? If you truly have a streaming data system in a company, like a streaming log like Kafka or Pulsar or something like that, you can essentially use it for so many use cases that are also pretty critical for the business. For example, it's great for data integration, right? You have lots of different data sources, different data destinations, third-party tools, and you want to be able to integrate all of this together, right? And I love mentioning this book called Enterprise Integration Patterns. It's about 20 years old, and it talks about all these messaging concepts.
Still relevant.
Yeah, it's still relevant. And if you think about Kafka and modern streaming systems, they're essentially iteration on top of messaging systems like ActiveMQ or RabbitMQ, with very different goals in mind. But still, if you open that book and look at the patterns, I think at least half of them are applicable to something like Kafka, right? So data integration, extremely important, very hard to do right. And something like a streaming log in the middle of your organization, I think that helps a lot. Now, think about all the AI craziness and ML, right? You really want fresh data for all kinds of use cases like personalization, recommendations, right? And it's really hard to get accurate personalization or relevant personalization with batch data that's like hours old. So that's also very important. And finally, what I really love talking about is what I call data applications, right? Massive amounts of data are sitting in this data lake or data warehouse, and companies don't really know how to use it. But if you really think about all the big tech companies like Netflix or Ubers of the world, right? They realize that all of this data is extremely useful, right? And I like saying that every single pixel on Netflix website is a result of a data pipeline, right? And I think it's pretty accurate. So putting this data in front of your users and building features that are useful and relevant for your end user, not for an exec who is waiting for a report, but for an actual user who's using your system. Like I think that used to be something that only big tech companies do. But nowadays, with more, with more flavors when it comes to databases, with more flavors when it comes to streaming engines, right? We're seeing this bigger adoption of this paradigm, and that was, for example, something my team really tried to build at Shopify, right? So we had a lot of data, and as a merchant in Shopify, you would be interested a lot about, the insights, how your business is doing, and there are so many things you care about. You care about orders, but you also care about shipping, but you also care about marketing channels, right? And we try to put all this data in front of a merchant, so that's very easy to use. And essentially, it's still a data pipeline, right? But building it with batch is really hard because it's not just about the latency aspect, which is a big one, right? But what I said about, for example, doing correction for late driving data, or just things like data enrichment, or that mentality of being an application developer and not just firing off this batch job and checking it after 6 hours. So all of these little things are needed to get this really good user experience in the end, I think.
Yeah. And you also bring up a good point, that is like today, again, there's still a big requirement for those executives to see what's going on as a report, right? But there's more and more need for all the middle tier or even the front line to understand what's going on and make a decision by themselves, right? So I guess that's also related to the debate or kind of upside down regarding this BI or UBI, right? So I guess for somehow our traditional thinking that is, hey, if we build a very nice dashboard, its main buyer and the user is the executive, right? But today, I guess more people need the decision making, and they need the data to help them to make decisions. And the data pipeline or data apps can really help. Do you think for the concept of data app or data product, do you think that's somehow the same? What's your inspiration for those ideas?
Yeah, data product, data application, I think it's pretty much the same. I think product kind of forces you to think a bit more holistically about it, right? So when it comes to data products, you usually have pretty good understanding about what you show in the UI, right? You have a product manager, you have customer interviews. You're really trying to make it as a product, and I think that's also one of the pillars of data mesh, right? To be able to build those data products consistently, fast, and with good accuracy, you need all these other data mesh aspects, because data product cannot be something that's built by a data platform team or data engineering team. Data product is by definition is cross-functional. So it might require you working with backend engineers, front-end engineers, PMs, designers, marketing, right? And that's just so exciting, in my opinion, right? It's when you really explain the value of data and you explain why users want this, and people can understand it, but when you see that demand and when you see that features can actually make a huge difference, when you put data in front of people, yeah, I think it's great, and I think this can be one of the drivers behind the whole data mesh aspect, because as an industry, I don't think we are very successful when it comes to building those products. Still by default, the data team, this data org somewhere is responsible for dealing with data, but I think it's actually not true, right? Data nowadays is something that's important for the whole company, and even if you're front-end engineer, back-end engineer, that doesn't matter, right? You need to understand how to use it, how to build different data products, what database to choose, what data technology to choose. I think we're slowly converging this data and software world. So hopefully it will happen soon.
Yeah. And also, I guess we can never understate the importance of data, right? Especially, I'm not sure whether you watched the video last week. I guess Elon Musk, they demonstrate this called end-to-end V12 self-driving, and they remove 90% of the code, and now there's no really rules in that engine. It's just the neural network to figure out whether they should stop the car or wait for other drivers. There's no rule at all, and On that topic is really that is the AI slash LLM now become how you can come up with very good data to feed into the model and get it out. You don't have to worry about those algorithms, data structure, whatsoever. In the blocks, it's handled by the LLM. But all you need is to figure out, hey, which, for example, like for the case of Tesla, which driver is a good driver. I should send the data and label it and put it into the model. And if which one is maybe angry driver or like a careless driver, and I should flag them and don't put them into the model, then it become part of like as a data problem, right? How to try to absorb all those data at the real time and measure the data quality, have enough context, and train your model. And people don't worry too much regarding what's kind of the algorithm or data structure or the details in the box, because that's handled by the LLM. But yeah, hopefully people will increase the demand and have a high expectation for data processing. And certainly streaming processing is not going to solve all the problems, but can help part of it. Yep. And by the way, that is you have very unique working experience. You mentioned Shopify, you mentioned Activision, like a gaming, and now in the Goldsky. I may be more curious, just from my personal perspective, about your use case in the Web3 or fintech. Right? I guess many people might know overall about the transaction, like those when we're in the school, like when you deposit from one bank to the other bank. That's typical database story. But is there any interesting story you can share with us regarding the Web3 and related to the data streaming?
Yeah, definitely. So as I mentioned, I work for a company called Goldsky. And what we're trying to achieve is we're trying to allow anyone who is interested in Web3 data, in blockchain data, to build very easy data pipelines. I think we now call it pipelines. If you think about it, like what is blockchain data, right? If you're not in the space and you hear about, Bitcoin or Ethereum or some other cryptocurrencies, or maybe NFTs, right? You think about those types of data sets, I guess, when it comes to data in blockchain space. And that's definitely like some of our customers do care about NFTs or do care about cryptocurrencies or like exchange rates and stuff like that. But if you learn just a little bit about the space, you'll quickly realize that the main use case here is what's called data from smart contracts, right? So blockchain, it's not, well, let's forget about cryptocurrencies for a second, right? Because it's not helping. It's not very helpful. Blockchain itself is a big database. Some people say it's questionable, right? It can be bottlenecked, but it's type of a database. But it's not just database, it's also a virtual machine. It's a big computer, because all these blockchain nodes, they can execute different instructions. So Ethereum, for example, it's probably the most popular one. It has a set of opcodes, just like JVM, for executing programs. And so blockchain itself gives you a building block for data storage, as well as the computing. And when you combine the two, you can build different applications, right? And so we see this big explosion of adoption of this idea. You don't hear a lot about this in the news because it's not as interesting as another scandal related to cryptocurrencies or NFTs or something. But there are a lot of people out there who are using this to build fully decentralized applications, right? So the way it works, you write the smart contract. So smart contract is a program in a special programming language like Solidity. There are frameworks now that allow you to use something like TypeScript, so it's way more friendly, right? You don't need to learn a new language. And when you write a smart contract, you essentially use those abstractions that blockchain gives you. For example, transactions or wallets or some other things, right? And you write this code and you deploy it onto the blockchain. So blockchain starts to execute your program. And for example, transactions to a certain wallet can be a trigger for your program, right? very interesting. I spent a lot of time kind of learning, and I was very excited because the tag is very, very interesting there. But what happens, when you write the program, you deploy it, it starts emitting logs. Just like any standard application out there, you emit logs and metrics and all kinds of telemetry. And so the same thing happens with blockchain. Any smart contract can emit events, what's called, or logs. And getting them out of blockchain is just like such a hard problem because it's not, first of all, it's not human-friendly format, right? It's not simple text or JSON or even Avro or protobuf. Like, it actually becomes part of the blockchain dataset itself, like block dataset itself. And you need to find a way to somehow parse the right, block, find the information that belongs to your smart contract, because blockchain is a big shared database and a shared computer, right? So you need to find specifically your events and then somehow, parse them, convert them to something that's human readable and use it, right? So a lot of the stuff that we do at Goldsky is building different data ingestion tools to allow you to easily get those types of events, right? You can deploy your smart contract using different blockchain providers, different tools, but there are not a lot of ways to get the data back from the blockchain, right? So that's something we're trying to address. And we decided because, this essentially becomes a data pipeline problem, right? Blockchain is your source, but you want the data to end up in, for example, your operational database like Postgres, or you want to maybe build search. So you use something like an OpenSearch, Elasticsearch, or you put it in a cache, or you put it in Key-value store, or somewhere, data lake, if you're doing some kind of analysis, right? And so this becomes a data pipeline problem, and blockchain, yes, it's a very special type of source, and you need to build some custom tools to ingest it. But in the end, once you, let's say, put it in something like Kafka, that becomes your, data pipeline building challenge. And one thing that is very, very interesting that I realized when I started working on this, with data streaming, we like to operate on a streaming log. So abstraction like Apache Kafka, where we have topics. Topics are pretty much immutable, right? You have partitions, and each partition is immutable. It's a log of events that happened. And if you think about blockchain, you can think about it as a partition of a Kafka topic, right? Because blockchain is a set of blocks, also sequential, they follow one by one, right? And they also immutable, almost. They almost immutable. And just like with immutable streaming data, that's immutable, you do have, for example, the problem of late arriving events. Okay. And also in blockchain, there's a concept of a reorg, because blockchain is a big decentralized computing platform, right? You have multiple nodes maybe competing for resources, and they could perform the same computation. But in the end, you need to reconcile all of these into one log that's acknowledged by the majority of the nodes in the system. And occasionally, if you reading data from a certain node, maybe it decided that the next block is this block A, but the other node decided that the next block is a block B. And this is called a reorg problem. And eventually, the nodes, when they exchange enough information, they agree, okay, so the block B is actually the right block that happens next, not block A. And again, if you think about streaming, that's just like late arriving data problem, right? Yeah. So the information that this block is no longer relevant, but this block is, you can model it as a late arriving data, and you can use things like retractions and upserts just to accommodate that in your system in the data pipeline. So yeah, it was very interesting to see that you can use very typical kind of data streaming primitives for something as different as blockchain.
Oh yeah, I didn't realize that the late event in this context is not really late on the 10 step. It's like, sorry, we thought you are the acknowledged one, but somehow other peer agreed that the other one is better, so we overwrite. Your state is out of date. It's not caused by the network latency. It's caused by this distributed P2P algorithm. Yeah, so interesting. And also, this I'm not sure about our audience, but that's also my first time to hearing that the blockchain itself can be kind of application platform, right, for you to use the distributed CPU, distributed memory or storage, and do certain interesting stuff with distributed log, all the fun stuff and the complex stuff. Wow, yeah, that's really eye-opening, at least for me. Cool. Yeah, so maybe we can also switch gear. I mean, we already talked about 15 minutes. So we all in Vancouver, right? And we even discussed very seriously which park we should be meet in person, holding some beer or not beer, coffee or tea together. Maybe we can do this soon or in San Jose during the current. We're all based in Vancouver. I'm kind of a newcomer. I only spent 5 years here. And that's also including 2 or 3 years about the COVID. I guess we might have mixed feeling about the COVID, especially from a person who really enjoy those technical conference or meetup. So what's your take on like engineering, software engineering in general as a community in Vancouver? I'm not sure even if we're talking about the data streaming, do you think you have a chance to talk to many folks in similar background? Or it's just you and me and maybe the other maybe 5% in the town? Is that what's your assessment for the current state, and what do you think? What's the direction for the tech community in Vancouver?
Yeah, and I've been living here for about 10 years, so slightly more experience, but not that much, right? But I think things were very different before COVID. That's pretty obvious. I remember going to a lot of meetups. There are not a lot of big conferences in Vancouver, but the meetup scene was amazing. I would go to a meetup and easily meet like 100 people, very passionate about a certain topic. I think companies like Hootsuite, Mobify,
Yep.
Unbounce, they were pretty cool. Like
And there's also a lot
magnets
of a
for
Web3 or blockchain company in Vancouver, right?
nowadays. Yes. But I'm just remembering those golden years of Vancouver tech scene before COVID, and I think things are very different here. Now, I don't think the meetup scene is fully recovered yet. Definitely see like way less activity going on. Maybe it's because a lot of people actually moved maybe to Vancouver Island or somewhere outside the city, because of COVID. Not sure if anything is going to change with the whole kind of returning back to the office theme that's going on, but also Vancouver. Gathered more big companies, right? So we had Amazon for a while, Microsoft, but I know we also have like Apple right now, for example. So things are slowly changing, and Vancouver was also great when it comes to, gaming or entertainment in general. So a lot of, I'm not sure if people know, but a lot of Hollywood movies or TV shows that are filmed in Vancouver, and there are a lot of studios here. For example, Sony Pictures ImageWorks. I think they have HQ here. They moved from LA many years ago. And when it comes to data streaming, I think Activision or its subsidiary Demonware. So Demonware was and is an Activision studio that's specifically focused on providing the online tools like data ingestion, for example, right? So I think Demonware was for a while sort of a way for a lot of people in Vancouver to learn about data streaming at scale. And then those people went to like other companies all over the city. Like I know a lot of people, for example, went to Salesforce and other similar companies. So that was the case, and I remember, running great meetups in the Demonware office again before COVID. So hopefully things can recover a bit. And there's also a conference called Polyglot that happens every spring. It's just a big conference that has a very interesting format called Unconference, where people gather and kind of pitch their ideas in the morning and then present them, discuss them in the afternoon, right? And I also I try to visit every one of them for the last several years, and clearly post-COVID things are still just ramping up. I think we had maybe a third of people a few months ago in the spring. So yeah, things are things are slowly improving, but still not at the not at the pace they were before.
Yeah. The interesting part of my self story that is the first year or the first 2 year for me in Vancouver. So I visit U.S. quite often, and my family is still in China, and they visit me sometimes. So for a while, I can join meetup every single night before COVID, right? So organized by different organizations, right? Can be software engineering, can be engineering manager, can be project manager, or fintech. I guess it's not really. On the other hand, maybe I'm not really pay so much attention to the meetup. I just join maybe few every week. Probably this the Vancouver Tech Journey morning meetup. That also I do realize that is on one end Vancouver is getting more and more expensive regarding the living cost, right? And also people don't really have to live nearby, right, in the downtown or in Vancouver in general. For example, in our case, Timeplus, we have we used to easy to meet each other. Now someone in Maple Ridge or in other places, it may take maybe more than 1 hour drive to meet. So I hearing similar feedback even for that Vancouver Tech Journey, the VTJ coffee meetup. People saying, can we meet in North Van? It's not easy to cross the bridge in the morning. Can we organize similar meetup in other places? People really take this opportunity to choose where is the best way to live without paying too much mortgage or rent. Some people move to Vancouver Island, as you mentioned. So maybe the offline meet will be more challenging. But again, on the other hand, it's very convenient to have a conference in Vancouver. Driving from Seattle to Vancouver is just 1 or 2 hours, depends on the traffic. And for example, this week, right now, right, they have this VLDB, the very large database tech conference or more academic conference happening in Vancouver downtown. Maybe I will even try to meet some of them later this week. Maybe it can be the other episode. Vancouver, I guess I do really enjoy the life here. People are very nice. It's not really as big as the Bay Area. I also like Bay Area. There are so many big companies, but also you have to drive at least 1 hour to meet each other. It's just norm. But in Vancouver, if I drive over half hour, I will say, oh, that's too much.
Yes. Great. And you mentioned VLDB, and I think you also told me about the paper, and so maybe you want to talk about one of the papers about the database.
Yeah. I just saw that kind of LinkedIn post maybe right now it's about 20 hours ago, put that way, right? So less than 24 hours. So I think that the team Feldera, right? So if I pronounce the name, so the team they won the best paper for this VLDB 2023 together with Frank from Materialize, right? So we all know that Materialize is one of the pioneer on the right now it's focusing on the cloud offering as a streaming database. So I took a quick look at the paper. I guess the key idea is how to turn any regular SQL to be streaming SQL without inventing extra syntax, right? So how to do incremental updates, how to maintain the state as a database or as an engine to work for streaming part, but without changing the SQL too much. So I'm looking forward to chat more with the team. They have this incubated in VMware. I think right now it's an independent company with open source offering. So that's more like a preview for my next episode, or maybe the next episode. I have the other one tomorrow, so the final one on Friday. So I will see how the experience looks like for 3 episodes 1 week. But again, I really enjoy that is talking to people from different companies, from different organizations, and we all try to be more creative to see regarding all the problems in the real world, how we can build a different product in different fashion to make them life easier. Okay, cool. I guess we cover almost everything on our list, right? So we are not really do a full script, but we do list the agenda. I cannot share the screen, but actually we have a Google Doc side by side, and right now there's a new feature in the Google Doc. You can set a timer, and we have all the checklists. It's very convenient for us to check, have a rough idea about what we've been talking about. Also, going to create a timestamped list in the YouTube so that you can jump to different sections easily. So Yaroslav, I asked quite a lot of questions, so I'm not sure whether there's any other comment you want to make or any question to me. Yeah.
Yeah, I do have a question. And you mentioned, for example, just mentioned this paper, that potentially can turn any SQL into streaming SQL, right? And I don't know, in my experience, using streaming SQL is extremely hard, extremely challenging. If you're doing a simple, filter or projection, things work really well, right? Because essentially SQL is just compiled to, a combination of maps and filters. But when it comes to streaming joins, which I think you mentioned a little bit, right, or aggregations, or maintaining session window, I think it's still very hard to use, right? I use Flink quite a bit, and when it comes to Flink SQL, it generally works, it runs, but if you want it to be performant, if you want it to be fast, you need to tune things quite a bit. You need to understand how state works. You need to understand how to, profile your Flink job. You need to understand about DB tuning and running on SSDs, and understand all the, batching that Flink can do for you and adjust it accordingly. And this is still like a lot to think about, right? And I think as an industry, data streaming, we made a lot of progress in the last 6-7 years or so, but it's still very, very hard to use if you truly have a use case that's demanding. And in the database world, you have lots of kind of ways to optimize, but I guess they're very, very not common, but people understand what an index is. People understand what a query plan is, right? Versus in the streaming world, you need to kind of know about things through the whole stack. So the question I'm trying to ask, do you think there's a way to solve that complexity somehow? Are you trying to solve it like in the context of Timeplus, maybe providing easier interface, a simpler SQL syntax or something? And where do you think we're gonna end up in a few years? Like if we're really trying to solve this problem?
Yeah, I totally hear you, and it's really a tough problem to solve, right? It's very different than, the optimization for a streaming engine or a general streaming database is very different than general database, right? For example, like the index don't really help too much for the streaming part, right? So the index in the traditional database is like if you have stuff like min-max index, then next time if you run a min-max function, you can just grab that number from the index without scanning all the data, right? But for the streaming side, the data is always flowing, and you might have arbitrary time window. So if you only talking about the aggregation or certain roll up for your streaming data, then the index is not really help too much. But again, sometimes people not just care about what's happening right now, they also wanted to see what's the data in the past. Then I'll give you a very simple example. Like for example, if someone wants to know how many GitHub projects or repo is created this year, right? Then it would be nice if you can have a way to using traditional OLAP technology to figure out like 1 hour ago, from January 1st to 1 hour ago, what's the total number? That might be probably already in the database. You can do certain kind of index, like count or min-max to get the number. But if you can have a way to figure out in the past 1 hour, or also for the next few minutes or hour, depends on how long your query should be, then what's the incremental data? You can add them together, and making sure there's no overlaps, right? You have to do certain kind of deduplication, or in our case, we're using the LSM, kind of like a sequence number in the log, making sure we can easily merge data in the OLAP and also in the streaming storage. So we can leverage both sides without causing some data compression. So that's the overall idea here in Timeplus. We try to merge the OLAP system and the streaming system. Again, we are not really as for example, like Flink, I don't know, maybe it's already 8 years or long, right? I mean, for Timeplus, it's just 2 years. So I'm not really trying to using the term whether it's mature or young, but it's different stage, right? And we are optimized for different things. And we just really wanted to make the overall data processing, no matter in the context of streaming or in the context of the historical processing, easier. Right? You don't have to look into the details regarding how Flink managed RocksDB or how watermark works. So in general, we should make this easy to use without looking at the document or even code. That's our goal, but again, there's a lot of details. We're also going to open core our engine, so that's something we are going to announce before the current. So for super kind of hands-on engineer like yourself, you can look into the details and see how things work and find out what's the best way, or even tune a little bit, or even send us a support request to improve it. But overall, we used the SQL as the primary interface. So there's no really lower level API. I mean, if you know SQL, you should be able to do those data processing, and it should work in most cases. And we might provide extra parameters, but those are optional. And also regarding the syntax is really a challenge, right? So I'm on the fence regarding whether we should just using the syntax from the SQL standard. But if you just look at the standard, there's so many different versions, and not every vendor implement all the versions, right? So people are still talking about what's the common version, like CQ92, something like that. People are still far behind to implementing the latest versions. And me and Gang and Ken from Timeplus, we actually joined this streaming CQ working group as part of the standardization organization to add extra streaming add-on to the CQ. For a while, the lead is in from Snowflake or from other companies, but there's a lot of challenge, right? So come up with a common agreement regarding what's the new syntax, what's the behavior semantics for streaming is a big challenge. Different vendors may see different use cases, and there's no really a strong kind of enforcement to implement the same thing in different vendors. So I'm saddened to see that discussion group was on hold. So there's no active meeting. Before that, it was like a few meetings every week, every month, but now there's no active meeting for that. I guess again, in the same time, if you look at this open source or commercial side, people being very active to see what's the solution they can provide. Snowflake also have a new offering, Databricks have a new offering, and like startup company like us, or there's a new open source project coming up almost every month. So I will also talk about them in our talk. But again,
so let me ask you.
Interesting stage.
I guess just to follow up. So do you think that this idea of a streaming database, where you have a streaming engine, but you also have this, maybe OLAP engine or key value store or something combined, so we can efficiently run historical queries and also use a streaming engine together. So this idea of streaming database, basically the next iteration of streaming systems. Do you think that's where we're going?
Yeah, at least from my perspective, that's a very promising direction, right? So we are not saying the streaming database will take over like Snowflake or those Databricks, data warehouse stuff. But compared to a streaming processor such as Flink, it provides more option for you to not just really as a cache, right? Because when you talk about cache, you mean, maybe I can keep it a cache for this hour, this second, but you should not expect you can query data like 2 months ago in the cache, right? Cache is cache. But in the case of streaming database, we give this mechanism for you to worry less regarding what should be in the cache. You just have a way to processing data in the real time, and you can assume the data will be in local storage. You can query with a join or with a CTE, or sometimes you can even just skip the streaming part, just cache whatever in the database. And if you want, you can have some tier storage to offload certain data back to your OLAP systems, but that's optional, right? So hopefully for some use cases, like for example for the streaming ETL, then that really works. The database part doesn't really help too much. But for other stuff, like if you do some, I don't know, maybe fraud detection, or some of the query need a certain context more than what's happening today, you might need a week as a context, or you want to have a system as your default option to run all the query, no matter it's real time or streaming. That can be a system. Otherwise, you have to build something like Trino, right? So it's more like federation search. It's the single gateway for your query, but it actually will dispatch the query to different systems and combine them together. But the drawback of that is you don't really have the much chance to do join in a meaningful way. And for example, this latency will be huge. But hopefully this idea of a streaming database can give a new option to be more performant compared to federation search, can reduce the complexity comparing to have a Kafka, have a Flink, have a Snowflake, everything together. Then this will be a single banner or single engine, so it makes things easier. And this should be more friendly for smaller team, right? If they are talking about they have a problem solved but don't really have a big team to set up a complex data pipeline or systems. Yeah. But again,
Great.
can be early stage. We are working very hard to make this happen, but it takes a lot of effort to make this really recognized by data engineers in this space. Yeah.
There's clearly something in this idea because there are several companies now building this, right, in different flavors. You mentioned Materialize before. There's Rising Wave and some other companies, in this space. So I'm very curious where it will go. For example, you mentioned, the SQL as this standard language to describe, and you said, even there's not even a standard that's uniform and everyone follow, and there's this working group, but maybe there's not much progress there. So it's interesting to see if we can truly use SQL for everything or not, right? And maybe the streaming database idea, it's great for like smaller medium teams, but when it comes to large companies, I'm afraid that sometimes the SQL is just not enough, right? And you have to fall back to some kind of like data stream, data frame type of API, in which case the idea of streaming database, it's a bit hard to marry with this kind of arbitrarily code execution, right? Yeah, so I'm curious where this will go, but I also see other interesting projects in the space that try to reduce the complexity. For example, Apache Arrow has a lot of development around data processing in general. There are an engine called Data Fusion as well as Ballista, I believe, and they essentially use Arrow format, an RPC to reinvent a data processing framework. And I think original idea behind Ballista was to replace Apache Spark. There's not much right now for streaming there. But I just love the idea of using Arrow or any other format for that matter, right? As a standard data format that doesn't need to be serialized, right? You can just copy it over between engines, languages, or frameworks, or storage layers, and it's a single format everywhere. Because I think a lot of computational power in streaming or data processing jobs in general is just spent like serializing and deserializing data, all the time, all over the place. Anytime you write it to another system, you have to, serialize, deserialize. And yeah, so I'm curious if that is also one of the potential solutions, not a complete solution, but something like Apache Arrow.
Require a lot of effort from different kind of domain to make this entire experience better, right? You mentioned Arrow. I guess when I was in Austin early this year, I also met some of the key developer of Arrow, and they convinced me that this is a really good format. You don't really worry too much regarding in-memory presentation, a memory network pack. So I guess there's more and more, the idea about GDBC, right? And they have this ADBC, which is Arrow-based data connectivity. And we also actively looking into this option. For example, in Timeplus, we potentially can have maybe this Arrow flight as a server. Then we can easily leverage all the GDBC or ODBC or ADBC driver from the community, right? So we don't have to invent our new version of drivers, right? So it will be very efficient.
Nice.
But I'm not quite sure whether Arrow can help a lot on those like watermark processing, later event aggregation. It's more like a data structure. So yeah, again, that can be joint effort. And also the other project I'm sure you pay attention to is the Paimon, right? Previous called the Flink table store, right? Mm-hmm. And right now I guess it's still in the incubation state. But for example, I have a lot of friend and connection in China. It's already used in production in many big companies. So it's a really interesting direction that is leveraging so many like Flink CDCs and all those not just connector, but also all those cluster and all those troubleshooting and all those tools to build a different data warehouse in a streaming friendly way, right? So they have very ambitious goal. Mm-hmm. They can be huge, and they also support both Flink and Spark or even other computing engine. So Flink is optional, even it's original from Flink, but it's not limited to Flink. So that's also the other direction, that is maybe we can imagine something similar to Databricks. That is, it's original from a computing engine, but slowly cover more end-to-end. No matter whether you want large data sets in a cheaper cost, or super high value data, but in low latency fashion. Hopefully one engine or one platform can cover most of them. Yeah.
Just one observation, all these things we discussed, they all try to consolidate multiple components together, right? Streaming engine and OLAP engine together, or data lake and streaming engine, or something else. So I think right now we just have too many things to to think about, and we just need to consolidate them and have like a nice uniform like engine to do things, right? So maybe batch, OLAP, and streaming all together or something. That's the dream.
Yeah, and also, by the way, that is coming from the Asia background. That was a famous book. But anyway, I mean, it's the first very line, just like, I forgot what's the book, that is, it is the best time and what is time, from Dickens, I think. But similarly, there's a book in China, I guess the first line is the entire world, it will collapse over time and it will unify again. So this kind of like circle thing, right? So I guess to some degree, people feel like, yeah, we can be very creative to be very good on certain piece, and then let's build an independent engine or component. And later on, people have so many of them and feel like, oh, come on, let's make things easier, have a standalone or unified one. And after that, people feel like, oh, I don't really have enough flexibility. I want a better performance for certain things. I don't need all of them. Maybe they will break again. So it's more like a cycle, but iterate over again, but maybe in differences, a better result in the end. Yeah. Okay, cool. Yeah, so I'm so glad to talk to you. We will publish this in YouTube or Spotify, and I'm looking forward to see you in person. Is that next month? Yeah, today is the last day. So in next month in San Jose, maybe hopefully we can have a coffee or kind of tea together.
Yeah, for sure. It's I think less than 4 weeks now. So yeah.
Yeah, and surprisingly, the weather is getting better in Vancouver. So yeah, so it's you never know. Again, so glad to have this talk. See you next time, or maybe in person.
Thank you.
Thank you. Yeah.